Okay, so this is lesson 6.2 and it has to do with inverse functions. If you took Math 1010, we went through all of this in 1010. So I think you're going to be just fine, and the rest of you will be fine as well. So one thing I need you to know is that if you have a function f, then the symbolism for the inverse is like f to the negative first. And sometimes they put an x with it. And then over here, you would then put an x with it. But just know that that's the symbolism for the inverse, okay? So let's start with example 1, find the domain. Well, you guys know that the domain is just a list of all of those x values, which I just highlighted in pink. So everybody put a brace right here, and then list those numbers, 0, 1, 2, 3, 4, close off your brace. The order doesn't matter, but I would really love you to just keep everything in the order it's given, because then I can grade faster, okay? The range is all of these y's, which I'm highlighting in yellow, so make your brace, and then the range is 0, 2, 4, 6, and 8, okay? And now they want you to list the inverse. So you're going to make a brace, and then you're going to take all of those ordered pairs, guys, and you're just going to switch the x's and y's. That's all an inverse is. So 0, 0 stays a 0, 0. 1, 2 becomes a 2, 1. 2, 4 becomes 4, 2. 3, 6 becomes 6, 3. And 4, 8 becomes 8, 4. And please make sure that you put that in braces. Okay, now they want the domain and the range of the inverse. You guys look at this notation. D to the negative first, that means the domain of the inverse, okay? So that's these numbers right here, these first numbers, domain's always the first ones. So make a brace, and your numbers are 0, 2, 4, 6, and 8, like that. And then the range of the inverse is all of the second numbers, which are 0, 1, 2, 3, and 4. Very simple, okay? This thing I think that you have highlighted that's on something, right? So look at the inverse. What that problem is saying is look at the inverse and then draw an arrow to that 8. And everybody tell me, is the 8 an x value or is it a y value? It's always the same, right? And I keep asking you that just to get that in your head. It's an x value. So they're saying if x is 8, then finish the question. Don't answer the question, but finish the question. What is y? Yeah. See how it says a colon? That's really not correct. It's supposed to be an equal sign, so change it. And what's the answer, everybody? 4. Good. Okay, I want you to write something down right here. I want you to write domain equals range equals. And then I want you to write domain of inverse, range of inverse. So compare the domain from the original and the range of the original to the domain and the range of the inverse. Everybody tell me what happens. I know you know. What is it? They switch. Well, it makes sense. Domain is x, range is y. So if you switch your x and y, then they're obviously going to switch. So draw an arrow right there, from there to there, and from there to there. And I want you to write down, they will always be identical, always. Okay, so it's really very simple. Okay, example 2. If f is a 1-to-1 function, there it is. Find f inverse of negative 2. 1-to-1, just so you guys know, just highlight this 1-to-1 right there and just draw an arrow to it. 1-to-1 means no y values repeat. Honestly, you guys, you don't even need to know that. You don't even need to know what 1-to-1 means. If a function is not 1-to-1, then it doesn't have an inverse. So the only reason that's in there is to tell you there really is an inverse, okay? Everybody write f to the negative first equals, and then make a brace, and write 2, negative 1, 5, 0, negative 2, 2, 6, 4, and close it off. And now they're saying, look at that, and if x is negative 2, what's y? So everybody write F inverse of negative 2 is equal to, what is it, everybody? It's 2, yeah. Do you really have to write out what the inverse is? Because they didn't ask me to do that. You really don't. You just have to find where the y is a negative 2, because they're going to switch, and then the x would be the answer. Who says I'm with you? Okay, so we already talked about one-to-one. So what you need to know about one-to-one, F has to be one-to-one, or it doesn't have an inverse. So F can't have any y's repeat. If it does have y's repeat, there's no inverse, okay? Is example 1 one-to-one? Everybody look at example 1 over here. Look at those y values right there, 0, 2, 4, 6, and 8. They're all different. So is it one-to-one? Everybody tell me that, guys. Yes, it is. If they're different, it is one-to-one. So I want to ask you a question. If you get a graph and they ask you if it's a function, how do you test if a graph is a function? Do you remember? It's the vertical line test, right? And now we're doing one-to-one. Well, the x's and y's switch, so your line is going to switch. So to test if something's one-to-one, you do a horizontal line test, okay? So this right here is not one-to-one because it hits it twice, okay? Now, just look forward for a second. If you want to write it on yours, I would love it if you did. But so look at this point right here. I'm just going to actually, just give me 2 seconds. If we draw our line exactly right there, okay? So just maybe erase yours if you didn't draw it right there. And then list that point. So that point is 2, 4. And then over here on the other side, negative 2, 4. What do you notice about those points? The y values are the same. If the y values are the same, then it's not one-to-one. So that's why the horizontal line test works. Because if you hit 2, the y's are the same, the answer's no. Who says I understand that? Okay, look at question B. Everybody in the room tell me, is the answer yes or is it no? Yes. It's yes. You're never going to draw a horizontal line that hits that graph more than once, okay? Everybody look at C, and I want you to just think about that for a second. What does that graph look like? And then do your horizontal line test. Is the answer yes or is it no? The answer is no. I don't know exactly what the graph looks like, but I do know that end behavior is up, parabola that opens up, because my biggest exponent is even, and it fails right there, so it's no. That's all I need to know, okay? All right. Okay, question 4. If a graph has 2 x-intercepts, then it is not one-to-one. So you guys, I'm telling you, whenever I get a question like this, I always draw the picture, okay? So just draw an xy axis, and then give it 2 x-intercepts. And you could draw a graph that, you know, satisfies that, like a circle or a parabola, whatever. But is that graph one-to-one anymore, guys? No, it's not. So if a graph has 2 x-intercepts, then it is not one-to-one. That is a true statement because it fails the horizontal line test. Okay? Okay, here's something that's important right here. If 2 things are inverses, remember the last lesson, composition of functions, where we took g of x and plugged it into f of x and vice versa? So if 2 things are inverses, look, you guys, if you take the inverse and you plug it in wherever you see an x into f of x, you get an x. And the reverse is true. If you take the original, you plug it in for x into f of x, you will also get an x. Okay? Okay, up above that, or up above example 5, I want you to put a little asterisk, and I want you to write down the words, take 1 step at a time. If you take more than 1 step at a time, then I don't know that you know how to simplify this correctly, okay? Show that these are inverses. I think this is highlighted, is it? There's one that's, I know there was something so close to this that was on Is anything else highlighted? Okay, I still want you to put some stars right here because I know there was something like this on the final, and it was unusual because they don't usually test this. Okay, so everybody just do this with me. All you have to do is find f of g of x, and then draw a line right here, and you have to find g of f of x, and it says show, so I know it's going to work, and these things should both be equal to x, because if they're inverses, you plug them into each other and you get an x, okay? Now, you can't fake it. You can't just write a bunch of garbage and say, yay, I got an x, because I'm going to look at the details of your work, okay? So see where you have that g of x? Replace it with what g of x is. So this is now just a review problem from last time. Now you go into this pink f of x, and right there where you see an x, you put in 7x plus 4. So you're going to have 7x plus 4 minus 4 over 7. Now, can I cancel the 7s right now? No, I can't, because it would be root to the 4s. But what can I do? The 4 minus 4 goes away, right? So then you have 7x over 7, and now the 7s cancel, and you get an x, and you're done. That's it. Freeze right here and look for just a second. You know how I told you to take one step at a time? What if a person did this? What if they didn't write this at all, and they just had this on their paper? Cancel the 7s, cancel the 4s, and I'm left with an x. I don't know what they canceled first, because they did it all in one. So you're not supposed to cancel the 7s first. You are supposed to cancel the 4s, but I can't tell which they did first. So that person would not get credit because they didn't take one step at a time. So just be really clear, okay? Okay, let's do the next one. This is g of x minus 4 over 7. Now you go into this yellow g of x, and right there, where you see an x, you have x minus 4 over 7. So everybody go 7 times x minus 4 over 7 plus 4. Can I cancel my 4s, everybody? No, but what can I do? My 7s, one on top, one on bottom, right? So I have x minus 4 plus 4. Now my 4s cancel, and I get an x, which is exactly what I was anticipating, and I'm done. That's it. Okay? Who says this lesson is easy? Let me see. Yay, isn't that wonderful? Okay. The graph of an inverse. Everybody just kind of kick back and watch, okay? So this yellow graph is your original graph, which has been labeled f of x, okay? This line right here is the line of reflection. The equation for that line is y equals x. So if you picked up that paper, and if you folded it across that red line, and if that pink was wet, right? When you folded it, where would it smear to? Well, it would smear over to that, and that's the inverse. So you just fold the paper along y equals x, it's reflected across that, and there's your inverse. Who says I understand that? Okay, so when you're graphing an inverse, the first thing I always want you to do is I always want you to graph the line y equals x. Okay, so take your pencil and draw in the line right there, y equals x. Now, I'm going to show you two different ways to do this. The way I do it is a little weird, but once it clicks to you, it's like so easy. You can just be like, boop, 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 boop. Okay, look right here. The distance, when I say diagonal, I'm talking about from the corner of a box to the corner of a box. When I say half a diagonal, I'm talking about that half diagonal, okay? So look at this point right here, guys. How far away is it from that line? Half diagonal. Continue along the same line, half diagonal on the other side, that point's going right there. Look at this guy, half diagonal, continue along the same line, half diagonal, it's going right there. You guys see the red line and the original graph where they hit? Put a dot right there, because the inverse is going to hit there as well. They all three hit at the same point. And then look at this guy right here, half diagonal, continue along the same line, half diagonal. Now see all those lines I drew to show you like the half diagonal stuff? You really can't have those there because it's really not part of it. I was just trying to do that to show you. And now all you have to do is go back to elementary school and play dot to dots. Wasn't that the greatest when we got to do that, right? Looks like that. And then you're going to label it F inverse of X, and you're done. Did you guys used to play dot to dots when you were little? From the 1 to the 2? Who said I did? Okay. I just didn't know if that was my era or yours. Yeah. So fun. Okay, here we go with example 7. So they give us a function. They give us the inverse. They want us to graph both and find the domain and range. So what I'm going to do, this tells you how to find the inverse, first of all. So basically, write your f of x as a y, switch your x and y, and solve for y, okay? For these problems right here, I'm going to give you a list of steps, okay? Step number 1, I want you to graph the original. So graph f of x. So everybody right here, write down y equals 2x minus 4. Let's graph it. Everybody tell me what that is. Is it a V? Is it a cubic? Is it a parabola? What is it? It's just a line, okay? So everybody go down 4, make a dot, and the slope is 2 over 1. So from that dot, you're going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, and you're going to draw that line very nice and long. And you're going to label it f of x. The second thing I want you to do is to find the domain and the range of f of x by looking at the graph. Look at that graph. Guys, domain is x. Start to the left. Move to the right. Everybody in the room, tell me what the domain is. All real numbers. Range is y. Start low. Move up. Everybody in the room, tell me what the range is. All real numbers. The third thing I want you to do is to find the domain of the inverse and the range of the inverse by switching. So this guy goes here, and this guy goes here. So this is all real numbers. This is all real numbers. Step number 4, I want you to graph the line y equals x. Okay, so go to that graph, make it very long and very accurate, and there's that line. Step number 5, I want you to graph the inverse by doing the diagonal trick. That looks weird. How do you spell diagonal? D-I-A-G. Come on, somebody help me. O-N-A-L. Okay, thanks. Okay, so see where the purple hits the red? Put a dot right there because you know that's going to touch your inverse. Then see this dot? Half diagonal, half diagonal. See this dot? Full diagonal, full diagonal. Technically, I could stop, but let's just make it really accurate. This guy right here, diagonal and a half. Continue the other direction, diagonal and a half. This guy right here, 2 full diagonals. 2 full diagonals. Drawing your line, and you always have to make sure you label it. Okay? And then the 6th and the last step is to find the equation for f inverse of x algebraically, which means show work. Okay? So everybody look at that. Y equals 2x minus 4. Take your y and make it an x. Take your x and make it a y. And then solve for y. So move your 4 over. So you have 2y equals x plus 4. And now you're going to divide by 2. When you do that, you get f inverse of x equals. But guys, I don't want to divide the whole thing by 2 because it's supposed to be a line and that looks weird. So I'm going to divide those separately by 2. The number that's in front of the x is a 1. So if you push that 1 and the 2 in front, that's just 1/2 x plus 4 over 2 is a 2, that's your answer. And you can actually take a second and look at that black line. You went up 2, up 1, right 2, it lies right on top of it. Okay, who says I'm totally good with that? Raise your hand, let me see. Okay, great. Okay. Question 8. Step number 1, graph the original. So everybody write y equals the square root of x plus 2. You guys, that's a square root graph shifted where? Everybody tell me where to go. Left 2. Tell me a normal stretch on a square root. What's my first step? 1, 1, right? Back to that dot. And what's the next one? Do you remember? It's not 2, 4, because the square root of 2 is not 4. It's 4, 2. Square root of 4 is 2. So I'm going to go right 4, up 2. So there's my graph. Label it f of x. Now look at the graph and let's find the domain. Start at the left, move to the right. Is the domain everything, guys? Yes or no? No. From the left, what's the first number you hit? A -2. Does it actually hit a -2? Yeah. Yes, so how do I close it? Bracket. With a bracket. And how far to the right does it go, everybody? Forever. Yeah. Now find the range. Range is y. Start low. What's the smallest y that touches that graph, everybody? 0. Does it actually touch it? Yes, it does. How high up does it go, guys? Forever. Okay, the next step is to find the inverse domain and range by switching. So this guy goes there, 0 to infinity. This guy goes here, -2 to infinity. Okay? All right, so the next step is to draw the line y equals x. Always make sure you put that on your graph, okay? So it looks like that. Now the next step is to graph the inverse using the diagonal trick. So put a dot right there because they're all going to touch in the same spot. See this point right here? Full diagonal, it goes right there. See this point right here? Full diagonal, it goes right there. And I'm going to draw it in, and it looks like that. And I'm going to label it f inverse of x. The last step is to find the equation for that algebraically. So everybody write x equals the square root of y plus 2. Switch your x's and y's. What am I going to do right now, guys? That y is trapped in the root. So what do? Square, not square root, square, right? So square both sides. So I have y plus 2 equals x squared. Pull my 2 over. You can't write y equals. You have to write f inverse of x equals. And it's x squared minus 2. And there's my equation. And now I'm confused. Because x squared minus 2 is a parabola shifted down 2. And I don't have a parabola on my graph. So what's happening? The domain of that black parabola is from 0 to infinity. So you've only taken the right side because that's where x is bigger than 0. Who says I understand? Okay, I want to show you one more thing. I told you...
Can I talk to Mackenzie Turley for a second?
I'm sorry?
Mackenzie Turley?
Are you going to beat her up?
No.
Are you sure?
Opposite stuff.
Okay.
Yeah.
Prop the door open. If he starts messing with you, honey, just scream. And Truman will come out. He's got your back. I told you guys the story about that.
Yeah.
It's true. Like, I don't know, 15 years ago, someone came to get another student and they were looking very, unofficial. And they were like, can I talk to so-and-so? I'm like, sure. Went out. The girl came back in crying. The girl tried to beat her up. She was like yelling at her and like pushing her and stuff. So now when anybody comes unofficial, I'm always like, you're going to beat them up. Okay. I told you I was going to give you another method. This is like a plan B in case you struggle, okay? So just sit back and watch for 2 seconds, okay? Look at your f of x. Some ordered pairs of that f of x are negative 2, 0, negative 1, 1, and 2, 2. That's f of x. So if I wanted to get some points for the inverse, I would just switch those. So 0, negative 2, 1, negative 2, 2, 2. 0, negative 2 is right there. 1, negative 1 is right there. 2, 2 is right there. And so I can get my inverse that way if I struggle a little bit. Okay? Okay, here we go with question 9. Same exact type of problem. Okay, so everybody write down y equals x to the third plus 1. Okay, so that's a cubic shifted where, everybody? Shifted up 1. So it's right here. Now, that's the center of my cubic. Do you remember the stretch of a cubic? What do you do? 1, 1. And then you balance it, left 1, down 1. Then you go back to that center and you go what, everybody? 2, 8 is correct. So that puts you 1 off your grid. And the 1 down here is the last point on the grid. And I'm doing lots and lots of points because I want this to be like super accurate. Okay? So it looks like that. Label it f of x. Everybody look at that graph and shout out, what is the domain of that graph, everybody? Let me wait for 2 seconds. Sorry, I feel like you're still graphing and I'm trying to move ahead. Okay, look forward for me. Everybody tell me, what's the domain? Everything, right? All real numbers. Range is y, start low, move up. What's the range, everybody? All real numbers. Therefore, the domain and the range of the inverse are also all real numbers. The next step is to draw the line. It's technically called graph the line, but whatever. Graph the line, y equals x. The next step is to do the diagonal trick, okay? So hits here, full diagonal, that should be half diagonal right there. My line's just a titch off. Looks like that. This guy right here is 2.5 diagonals, so that's going to be over there. Yeah. So it looks like this. Label it f inverse of x. Okay. Now let's make your x a y and your y an x. And now let's solve for y. So pull your 1 over. Y to the third equals x minus 1. How do you solve that for y, everybody? What do? Cube root it is exactly right. So now your equation is f inverse of x is equal to the cube root of x minus 1. And we're done. Okay. Hey, Truman, do me a favor and close the door, will you? Okay, here's question number 10. Everybody write down y equals x squared minus 3. That's a parabola shifted down 3. Normal stretch, right 1 up 1, left 1 down 1, or pardon me, left 1 up 1, right 2 up 4, left 2 up 4, draw in your graph. I want to ask you a question. Just look right here. What if someone just gave you the graph and they asked you to draw the inverse of that graph? Does anybody know what the answer would be?
There is no inverse.
Say it again.
There is no inverse.
There is no inverse. You're so smart. Literally, you're so smart. There is no inverse. Why is there no inverse, honey?
Because it doesn't pass the horizontal line.
It's not 1-to-1. If it's not 1-to-1, there is no inverse. Now, I don't think Weber's going to do that to you. Utah State used to do that. Like 10 years ago, I taught this class through Utah State, and they used to try to trick you. And you had to remember, if it's not 1 to 1, there is no inverse. I don't think Weber's going to do that to you. Look right here. They only want the graph to be there if x is greater than 1. So grab your pencil and erase all the right side, because that's not greater than 1, okay? And then let's kind of take this side over here, guys, and let's extend it really, it just goes really steep like that. And let's label it f of x. Now the next thing you're supposed to do on that list I gave you was to come up with the domain of that graph. So if you travel from the left to the right, everybody in the room tell me the first value it's going to hit. 0. Let's write it in inequality form, just in case they ask you. So it's 0 and bigger or 0 and smaller? 0 and bigger. So that would be x is greater than or equal to 0. Let's do the y. The smallest y that it's going to hit is a what, everybody? -3 on up. Is everything okay?
Yeah, but is it okay if I go?
Yeah, you're good, honey. Just watch the video, okay? Where are you going?
Family.
Oh, okay. You're great. You're great. That's your business. I just didn't know if you were doing a school thing. I'm like, I better find out. Okay, so y, just check out in the office, okay, honey? So it's y is greater than or equal to -3. -3 and bigger. The next thing is to switch these. So that guy goes there, and that guy goes there. And it looks like that, and that's wrong. Why is that wrong? Yeah, domain is x and range is y. So that's why I wrote it in inequality form, to be honest with you. I just wanted to have that conversation that yes, they completely match, but you have to make domain x's and range y, okay? Okay, the next step is to draw the line y equals x. The next step is to do the diagonal trick. Guys, the first thing I always do, see where the purple touches the red? I always put a dot there. It's my first dot. This guy right here, half diagonal. This guy right here, diagonal and a half. Starting point, diagonal and a half. It's going to curve up, and it's going to go like that. And I'm going to label it f inverse of x. The last thing I have to do is come up with the equation algebraically. So it would be x equals y to the second minus 3. Pull your 3 over and it becomes a positive. You have y to the second equals x plus 3. Tell me what to do now. Square root it. When you square root it, what has to come right after the equal sign? Plus or minus the square root of x plus 3. And that's wrong. That's wrong. Somebody tell me what's wrong. Go ahead, honey.
Because you already know that it's over 3 and
It's okay. It's okay. What's the right answer? Say that.
it's just a positive.
How do you know it's not the negative? Like, tell us what's in your head.
It's not reflected over the x.
Man, you guys are amazing. That's exactly what I was going to say. So look, a normal square root looks like that. If you have a negative in front, the graph would look like that. Does that black graph look like that? No. So I know it's not the negative. I know it's just the positive. Good. Okay? Okay, examples 11 and 12, and then we're done. Find the inverse, and then state the domain of f and the range using the inverse. Okay, so it's a little confusing, like what are they asking me for? Is this highlighted?
No.
Nothing left is highlighted. Okay, still want you to put a little star, because I have seen this recently. Not obviously last semester it would be highlighted, but I have seen it recently. Here's what they want to know. They want to know what is the inverse. Then they want to know the domain of the original and the range of the original. One of them I can find right now. I don't even have to show any work. Which of those 3 things can I find right now? I'm looking for the inverse. Can't do that immediately, right? The domain of the original, the range of the original. Which one can I find right now?
The
Domain.
Domain of the original. So you take the denominator, you state the denominator cannot be 0, so I know x cannot be equal to 1/2. There's one of my 3 answers.
Would it be negative 1/2?
Yes.
Put the negative.
I wrote negative, I think I didn't say it. Okay, let's find the inverse. This is kind of tricky, little tough, so watch, okay? F of x is y. So make it x equals, switch the x and y minus 3 over 2y plus 1. This is tough. Now I'm going to put a 1 underneath the x. I'm going to cross multiply, and I'm going to distribute. When I do that, I get 2xy plus x equals y minus 3. Now I want everyone to freeze right here. I'm going to have you guys figure this out. I'm trying to solve for y. I have y's on the right and y's on the left. If I was trying to solve for x right here, look right here, you don't have to write this down. If I was trying to solve for x right there in that equation, what would be my next step? Everybody tell me that.
Isolate the x.
Say it again.
Isolate the x or get both x's on the same side.
Yeah, just tell me in general, everybody. What would my next, specific. Tell me specifically, what would you do to that problem?
Move the 2 over.
Move, I wouldn't move. I'd probably move the 5 to the 2 or the 2 to the 5, it doesn't matter. So I'd get my x's together. Who says I understand that? Okay, so down here, I'm trying to, and then after that, after I get my x's together, then what else would I do? Maybe in the same step. Use the non-x's on the other side. So I'd put x's on one side, non-x's on another, so I can solve it. Who says I understand that? Okay, so come over here. And now let's get everything that has a y on one side and everything that doesn't have a y on the other. So see this y right here? I'm going to pull it over, and it's going to be right there. So it's going to be 2xy minus y equals. Now this x has to come over to that side. So now I have negative x minus 3. So all I did is move the y to the left and the x to the right. Okay? Now, I'm trying to solve for y, and I cannot add those two things together because one of them has an x and the other one doesn't have an x. What do? The answer is not divide by y. Divide by y doesn't do anything. Does anybody have any idea what we can do? No. And you know, I'm just going to say no. Because then I'd have a lot of fractions. It would help this guy, but then this guy would have a 2x underneath it, so it doesn't really help. What do? Guys, I'm trying to get the y alone. I'm trying to pull out the y's and get everything else on the other side. That was a big hint. Go ahead, honey.
So you take out the y because they both have a y attached.
You're exactly right. They both have a y, right? So let's pull out that y. When you pull out that y, you're left with 2x minus 1. Now, everybody that can tell me, how do I get the y alone now? What do?
Divide by 2x.
That 2x minus 1 is multiplied, so just divide. So then the answer is, the inverse is negative x minus 3 over 2x minus 1. That's it. You're going to see that again. That will not be the only time you see that, okay? Okay, so that's my inverse, which is my second answer. Now I need one more answer. I need to know the range of the original. And I don't want to graph it. Somebody tell me how to find the range of the original.
It's the domain of the inverse.
It's the domain of the inverse. So if you look at that inverse, the domain of the inverse is x cannot be 1/2. That's the domain of the inverse. Therefore, the range of the original is y cannot be equal to 1/2. That's your answer. Done. Who says I followed you? Give me feedback how we're doing. Okay, one more problem when we're done. Here's the original. Here's the inverse. What is the range of f? They want to know. The range of f means the range of the original. Finish my sentence. The range of the original is the same as the
Domain.
domain of the
Inverse.
inverse. So here's my domain. Here's my inverse, I mean. What's the domain? X cannot be 2. So the range of the original is it X cannot be 2? Y cannot be 2. Done. Who says I feel good about this? I understand. Okay, good. Okay, let's get those quizzes back.